Hey guys, this is for National 5 Pupils of Geography. It's the third out of three lessons on environmental hazards. Um, Once again, I won't go through all the basics like I did in lesson 1. We are dealing with the causes, the impacts, and the solutions to a hurricane that we've studied. Previous lessons referred to volcanoes and earthquakes. So let's get started. Hurricanes is your title. If you're not sure, you should use that as your title and write that down. And first of all, let's get straight stuck into the exam question that we're dealing with here, which is the explanation of how a tropical storm forms. And it's quite nice to just have a look at some pictures before we start. A few little major features of a hurricane. First of all, it's obvious they spin. But people find they can be a little bit confusing in actually how they move, because they are a complex structure. They're not simply as simple as just a spinning top of air. This image in the right hand side is particularly useful because it shows you the shape of a hurricane as a three-dimensional object. Not only is it spinning round and round and round, but it dives down. Can you see? This is like a funnel. And that funnel down the middle is called the eye of the storm. The eye of the storm you see tracking on this heat map, and the eye of the storm you see on this static image. And it will help you to understand if you can see that that is like a funnel down which air can disappear. The diagrams on the right hand side try to demonstrate how the air moves within a hurricane. Before we even get to the text, let me try to explain it to you. Basically, warm air rises, and as it rises up, it cools down, and so it sinks. As the cool air then sinks back down towards the surface of the Earth, it is then heated again and is forced back up. And this constant rising, falling movement of the air causes the cloud formation to become truly massive. Because the rising air is warm, it can absorb lots of moisture. So every time it rises, it carries moisture up into the sky. Every time it cools and falls, it's allowed to then recharge with moisture before being forced to rise again. So moisture is carried into the sky by this repeated rising and falling, rising of warm air and falling of cool air. If you look at this lower diagram, you can see the rising warm air and then the cooling descending air. If nothing else, all you need to have taken so far is that hurricanes are made of rising warm air and falling cool air, and that this causes lots of moisture to be recycled into the sky to make big clouds. Okay. The sea has to be 27 degrees Celsius for this process to take place. The seawater has to be warm enough for it to evaporate and then rise up into the sky. If you've not got 27 degrees, then the seawater is not warm enough to fuel that process. As a result, the air above the warm sea is heated and rises. Warm air is called low pressure air. That means that when you have warm air, there are fewer molecules of air in any given area. High pressure air would be the opposite. High pressure air would have lots of molecules of air in a given area. If there are fewer molecules of air, this means the air has more spaces between its molecules to absorb moisture. So warm air expands, warm things expand, warm air expands. Therefore, the spaces between its molecules get greater. We call that low pressure. And therefore it can absorb lots of moisture. Rewinding all the way to the beginning, the sea needs to be very warm to fuel evaporation. Because of that, the warm air rises. Because of that, we have something called low pressure air, which means that moisture can be absorbed. As this moist, warm, low pressure air rises up into the sky, it condenses and forms clouds. But cool air descends, sinking back down the central eye of the storm before being heated and rising again, and that's that up-down heating and cooling thing I was talking about a moment ago. So far, we've just described warm air rising, getting cold and sinking, and warm air carrying moisture up into the sky, forming clouds before cooling and sinking. But hurricanes aren't as simple as just a column of rising and sinking air. They also spin. So let's deal with the spinning. The hurricanes spin because of the spin of the Earth's surface. Okay? Due to the spin of the Earth, hurricanes in the northern hemisphere spin anti-clockwise. There's loads of demonstrations that we can do in class of this. But due to the Earth's movement, this causes liquids and gases on the Earth's surface to spin as the Earth moves underneath them. So the spin of the Earth causes a hurricane to move in an anti-clockwise direction. Furthermore, the wind direction across the Atlantic Ocean is mainly from the east to the west, and so the hurricanes mainly blow from the east to the west. So we can talk about how the rising warm air carries moisture into the sky, and how the cooling air sinks, and this forms this cycle of cloud formation. And we can talk about the spin of the Earth making the hurricane spin anti-clockwise, and we can talk about the wind direction on the Atlantic forcing hurricanes to blow from the east to the west. Spend time with this clip, replay it a few times, look at the images for a while, don't just look at them passively and not try and take them in. This isn't easy stuff, and you need to spend a little bit of time thinking about it and trying to imagine the process. Okay, here is a model answer. For those of you that just want to know what to say, when to say it, and how to say it, this is what to say. Copy this down. I'm not going to help you to fill in the blanks. You should be able to work that out for yourself. Here are the keywords. If you don't know where to get the answers, it's because you haven't listened to my explanation earlier in this video, and you haven't read the text earlier in this video. So copy this answer out and complete it. It's worth 6 marks. The next exam question that we would look at is, for a tropical storm you've studied, explain in detail the impacts of the storm on the people and the environment. Now, just before we get into this, you need to focus on 2 things. 1, you need to have a named example, and 2, you need to talk about people and the environment. If you don't, you can't score 6 marks. So I'm going to do this by showing you loads of pictures. Notice that each picture has a label attached to it. That's to help you. But don't just think that you can just write down, for example, that 1,800 people died and you'll pick up marks. You're trying to write a paragraph here, and paragraphs are made of sentences. Okay, so let's start off with, though, the case study in question. And the case study in question is Hurricane Katrina 2005. I always say this when we get into case studies. It's not enough just to start your answer, in Hurricane Katrina, people died and buildings were destroyed. That's not enough. You need to provide places, dates, numbers, examples, real facts and real figures that back up your understanding of a real case study. You, in other words, need the level of detail that I'll take you through right now. You can see in the image on the right hand side all sorts of different facts about the hurricane that hit New Orleans in 2005. On the 26th of August 2005, a huge hurricane called Hurricane Katrina made landfall in the southeast of the United States. It hit the town of New Orleans worst, but it actually badly affected a whole series of states along the southern coastline. But we're going to focus on the New Orleans impacts. New Orleans is a big city, and 1.2 million people had to be evacuated. However, 10,000 people had no transport or didn't have the ability to get evacuated. So they had to shelter, and the American authorities weren't really very well prepared for the disaster, so they had to convert the local sports arena called the Superdome into an emergency evacuation area. So poorly organised and so desperate were the people that there were real problems with civil disobedience, and there were quite a few issues with violence breaking out, and there being quite a lot of difficulties with that the authorities had to control. The storm surge, this is a big wave that the hurricane blows in front of it, broke the defence levee. The defence levee, if you haven't been taught that yet, is the dotted line on the map that you see to the right hand side. A levee is a wall that you build out of concrete, and it is basically there to defend a city against rising water. It's a flood defence wall. That's what it is, and it's called a levee. However, this levee was broken in over 50 places. As a result, the city was 80% flooded in up to 5 meters depth of water. A classroom is 3 meters high. So 5 meters depth is really, really serious, and obviously that took a long time to drain away. As I pointed out, 1,800 people died during the storm. It was a tragedy. Many people were trapped on the roofs of their houses because of the speed of the storm as it arrived. They just didn't have time to respond, and so they had to wait rescue with no food and no shelter on the roofs of their houses. In many ways, this was one of the worst hurricanes to affect the United States, though actually it's only the third worst in terms of death toll. Loads of houses were boarded up. You'll have seen that in your lessons, and that was to stop looting, because there were big problems with so many people having evacuated the city that some of the people who stayed behind actually then decided to loot people's homes and businesses. And that in itself is an impact of the hurricane. 800,000 homes being destroyed made this one of the worst homelessness crises that the United States has faced in recent years. And because of the flooded streets, it meant that the only way of getting around was with boats. And of course the water isn't like a nice river, it's full of rubble and rubbish and broken buildings, and so it's actually quite difficult to navigate. So it took a long time for any rescuers to get from A to B to find bodies or people who had survived. What you see in front of you is a really high quality answer, and you need to try and kind of recreate that, to be honest. But it's really difficult to remember that without some pictures. So here we are. Let's have a look at some pictures. You can see here people writing signs on their roofs because they were totally isolated and shut off behind meters of floodwater. You can see the floodwater here is very deep. This meant they were trapped, and so their phones didn't work, there was no internet connection, so their only way of communicating was to write their help signals on their roofs, and this allowed helicopters to identify where survivors were. Another good thing to know, you'd score marks with all of this, is that there were billions of dollars of damage, and it's still being repaired today in 2020. These colours on this map show the percentage of property loss, with purple being more than 90% and red being 17 to 90%. Just imagine if your house was one of those. This map on the right hand side shows us death counts as numbers of deaths per thousands of people that remained. what that means is that in the red zone, 30 to 50 deaths occurred per every 1,000 people that remained. That's a difficult number to interpret, but I can assure you it's very, very high. Only around 100,000 people stayed in the city. This means, if you're not willing to do the maths, I'll do it for you. 2% of everybody who stayed, so of every 100 people, 2 of them died. If I told you that you were in a building with 100 people and 2 of you are definitely going to die, you probably wouldn't like those odds. And that's one of the problems, because not everybody evacuated. Some people didn't trust the authorities. Some people didn't believe what they were seeing in the media. Some people just didn't want to take the advice. So 100,000 people stayed. Some people were afraid that their houses would get looted, not without justification. But 2% of those people paid for that decision with their lives. 80% of the city was flooded, and it was only accessible to rescuers by boat. This means sewer systems were flooded, parks were flooded. The pollution in the sewers, of course, flooded up into the streets, and that became a public health crisis. The flooding meant that rotting bodies could transmit disease through the water. Fixing this problem is not a matter of just draining the water away. It's the damage that the water reveals once it's drained, as much as anything else. Here in the right, you can see the Superdome. This is a sports arena. It was used to shelter 10,000 people, but don't get carried away with your notions of that. It's not like in the movies. If you look at this picture, you can see that many of these people are in sleeping bags, and only a proportion of them are lucky enough to have a camp bed. The American authorities were caught out with this natural disaster, and this was not a planned emergency strategy. This was an emergency reaction to an unfolding disaster in New Orleans, and 10,000 people had to be given shelter here. An interesting fact is the National Guard had to provide security at the gates to check everybody coming in here for guns, because so high is the gun ownership in America, and so absent were the police in New Orleans, most of them having evacuated or themselves being caught up in the flooding, that essentially this was an entirely lawless situation, and serious crime was something that the authorities found themselves having an increasingly difficult time tackling, because basically the usual rules of society had started to break down. Rescuers would put X codes on on doors. You'll see a photo of these earlier in the lesson as well. An X code is the way of recording which houses have been searched. So, for example, if you look here, this shows you the date of the search, 9/12. So in American, because they do it the other way around, that would be 12th September. INT means entered, I believe. I think I've done my research right. And I think NE means no entry made. If you look at other pictures of these, you'll see them. This code here refers to the search party that carried out the search, and this refers to the number of dead bodies inside. 1D, 1 dead. You'll often see them refer to cats and dogs and animals and things like that too. That's not that is out of respect to the owners of their pets, but also because rotting bodies spread disease, so we need to know about animals too. So that leads us to our third and final question, which is for sorry, that shouldn't say earthquake, that should say hurricane. Apologies. For a hurricane you've studied, explain the strategies used to reduce the impacts of a hurricane you've studied. I've not done a very good job of typing that question. So we're explaining the strategies used to reduce the impact of a hurricane. Well, I've kind of covered a few of these in the pictures earlier, so let me just talk you back through them. The Superdome was used as an emergency evacuation point for 10,000 people. That's one mark. The National Guard were called in to assist with the rescue and keeping the peace, along with clearing dead bodies. X codes were used to mark houses which had been searched and which ones contained bodies. Pumps were used to clear the floodwaters, and sand gravel bags were dropped to help those broken levees. Remember, the levees were the concrete walls that tried to stop the floodwaters in the first place. Houses were boarded up to stop looting. FEMA, standing for the Federal Emergency Management Agency, eventually got round to, it took 5 days, but they eventually organised drop-offs of food and fresh water, but it did take days, and they were heavily criticised for that. A hospital ship was organised to sit off the New Orleans coastline. And DMATs, that stands for Disaster Medical Assistant Teams, they were able to set up field hospitals within hours of the disaster. Those are a military organisation. So those are 7 things that they did to solve the problems of Hurricane Katrina, and you would need to quote at least 6 of them to get 6 out of 6 and an A in that question. That brings us to the end of the hurricane section of the Environmental Hazards unit. Across the 3 videos you'll find in this section, volcanoes, earthquakes and hurricanes, I know there's a lot of material, and I know that there's a lot of detail. And it is worth spending time with these videos, listening to me more than once, maybe turning the sound off and copying the notes down, and making sure that you attempt each of the 3 questions for the causes, impacts and solutions to volcanoes, earthquakes and hurricanes. Make sure that those are in your notes. Alright,